All right, I love problems like this. This is the second page of notes for interpreting functions. And problems like this where you are given a table of values. There are two continuous functions, f of x and g of x, and the table is going to help us answer all the questions. I want you to push pause really quick. I know some of you will, some of you won't, but it is actually super helpful because it's going to be a problem just like one on the test. Push pause, try problems 15 through 19. If you get stuck, move on, and I'll go over them in just a second. So push pause, push play when you're ready. All right, we are going to look at some of these in this section, and we are going to start with g of -3. So I will find where the input, remember, that is an x value for -3, and I'm going to figure out what the output is for my g of -3. So here is -3, and when I look to see what g is at -3, it is equal to -5 for my y value, or my g of x value. So that is all for problem number 1. We would say g of -3 equals -5. Now, for what values is f of x equal to 0? So it's saying, when is f of x 0? Well, we need to find all the places where f of x is 0. No, yes, and yes. There are only 2 places where f of x equals 0. So what are the x values that create a 0 f of x? Well, one of them is x equals 1. The other one is x equals 2. That's all. You write down those 2 values. On the homework, you might just write 1, 2, if I ask you to do it that way. All right, now problems like this always throw people off because you really have to kind of get out of your mind. When you think of increasing, you think of a graph. But on this one, we are only given a table of values. So we need to find when f of x, this column, is increasing. So we start at 42, we go down to 30. That is not an increase. 30 goes down to 20, down to 12, down to 6, down to 2, down to 0, stays at 0. But then it goes from 0 to 2, and that's an increase. So I know that my increase starts at that 0. And then it goes 2 to 6, that's still an increase. 6 to 12 is still an increase. 12 to 20 is still an increase. So that section right there was an increase. However, we cannot write on our graph 0, 20. We need to always use our inputs as an x value. So that is really from 2 to 6. So from 2 to 6, the function was increasing. I hope that made sense. So we found where the numbers increased, and then we used the x values to describe what the input was when it was increasing. Okay, on what interval is g of x greater than f of x? So we are going to look at our graph, our tables, and we're going to find when the g of x numbers are greater than the f of x numbers. Right here, -13 is not greater than 42. -9 is not greater than 30. -5 is not greater than 20. -1 is not greater than 12. 3 is not greater than 6. But 7 is greater than 2. 11 is greater than 0. 15 is greater than 0. 19 is greater than 2. 23 is greater than 6. 27 is greater than 12. And 31 is greater than 20. So that whole section, the g values were bigger than the f values. So we'll go back to the x is, our inputs, and we can say from 0 to 6, g of x was bigger than f of x. So from 0 to 6. All right, last one. Which function is changing faster in the interval from from -5 to 0? So we are looking at this interval, -5 to 0. So we know that f of x goes from 42 to 2. And if I found my slope for that, I'm going to say f of x, that is decreasing by 40. So I'd say -40 for the change in y. And then from -5 to 0, that's going up 5 spaces. So -40 divided by 5 gives me -8. Now, if I do the same thing for g of x, I start at -13 and I end at 7. So g of x, what's that difference? How do I go from negative 13 to 7? Well, I go up the 13 spaces out of the negative, then I go up 7 more to get to 7. So 13 and 7 combined would be raising up 20 overall, and it still went up 5 from negative 5 to 0. And when I divide that, I get 4. So which one's changing faster? This one, f of x. How do I know? Because I just did the math on it, you weirdo. Okay, that is good enough for our explanation. I want you to push pause, and I want you to try the bottom 20 through 25, and then we'll talk about them. I know they're kind of difficult, but you can try them. I bet you can get a lot of them done, and this will help you for that test prep. Push pause. Okay, on problem number 20, explain which of the above relations are functions. Okay, all of these are functions when they have every input giving one output. So right here, every exponent there would give one output. Every input here would give one output. This one is always just giving the output of 5, that's fine. This one though, the input's always 4. That poses an issue. Since the input is always 4, 4 can give so many different outputs. So we would say and this one, every input would give you one output. So all but x equals 4, because the same input, oh my gosh, input has many different outputs. Okay, the next one, find f of 2, g of 2, and h of 2. So when I do f of 2, I'm going to do that work over here. I'll start with this f of x equation. I will say f of 2 equals 3 times 2 minus 2. 3 times 2 is 6. 6 minus 2 is 4. So f of 2 equals 4. Let's do the same thing for g of 2. For g of 2, I know that the equation tells me it equals 5. That's all. I don't put like a 2 in there anywhere. It's just 5. That would be your final answer. Just like our final answer on the last one would be f of 2 equals 4. I know, it's weird. It feels kind of different, but it's actually way simple. Okay, h of 2, the equation was right here. It was 2 to the power of x. So I'd say h of 2 equals 2 to the power of 2. And I know 2 squared would give me h of 2 equals 4. And those are my 3 answers. That's all I'm doing there. Okay, write an equation for g of x plus h of x. Well, I know that g of x is 5 and h of x is 2 to the power of x. So if I'm just adding those, that's like literally just my answer, 5 plus 2 to the power of x. All right, this next one, where is f of x greater than g of x? Let's think about that. So it's saying when is 3x minus 2 bigger than 5? Okay, so we can just say our equation like this. 3x minus 2 is less than 5. Let's start solving that thing for x. So I can add 2 to both sides, and I get 3x is less than 7. Then I can divide by 3, and I get x is less than 7/3. So basically it's saying whenever x is lower than 7/3, this is going to be true. So to say that, we would go, we would say that everything lower than 7/3 works. That would be negative infinity up to 7/3. But that doesn't have an equal to, so I have to put an open parenthesis. That was kind of a tough one. I hope that you followed along with that. We set the equation up, we solved for x, and then we thought of what that would look like on the number line. If you remember back to our inequality unit, that would have 7/3, and we would have an open circle, everything shaded below, which is where we get that negative infinity from. And then the 7/3 with the open circle came from the other side, where it ended at 7/3 without filling in the circle. Okay, where is f of x increasing? Where is f of x increasing? Well, I know that f of x is equal to 3x minus 2. What is the rate of change there? The rate of change is positive 3. That means that it's always going uphill. So where is it increasing? Everywhere. It's an increasing function. You can say negative infinity to infinity or all real numbers. When you get to high school and college, they actually have a separate way of doing this. To say all real numbers, they like make this weird R like that. So if you ever see that, just know that that means all real numbers. I'm just gonna write that. All real numbers. No, I'm not going to put it like that on the test, but I would like you to be aware of what that symbol means. Okay, which function has the fastest growth? H of x is exponential. We know that that's always moving quickly. G of x, or f of x, has a change of 3. G of x is not changing at all. It's flat, not very fast. X equals 4. That has an undefined rate of change, so that one we're not going to count. This one is faster than f of x because the rate of change is 5, but neither of them will beat that exponential function. So we are going to say h of x because it's exponential. And I think I forgot an apostrophe here because my advisory class taught me that you're supposed to put apostrophes when it is, unless I forgot and remembered that wrong, in which case, don't tell me. All right, do your best, ninth graders. You can get tonight's homework done. Let me or Mr. Bodley know if you have any questions.